All right, so let's work through some problems to illustrate how to use this table. So here's our example problem number 1. What percent is above, what percent of a normal distribution is above z equals 0.98? All right, so my advice always when solving these kinds of problems is to first draw a normal distribution. And then color in what you're trying to figure out. So we want to figure out the percent above z equals 0.98. So we know, so 0, 1, 2, 3. So we're looking for a little bit below here, 0.98. It's going to be right around there. So we want that plus everything above it. And we want to solve this problem with the information that's available on the table. So first off, we find that the z-score we're looking for is 0.98. And of course, we have the part of the table we need handy here. And so what we can do is try to figure out what percent is above and beyond that. So the easiest way to solve this problem would be to actually look right here. So this number is the percent in the tail. The percent to that is in the normal distribution in the tail beyond that z-score. So that is the area we're looking for, 16.35%. That is the percent that is above 0.98. There's another way we could have solved it if we wanted to, which would have been a bit trickier. But right, the overall area of the whole distribution is 100%. So we could have subtracted out everything else. And what would remain would be what we're interested in here. So if we did it that way, we know that below the mean is half the distribution. So that's part of what we're going to get rid of. But we also need to get rid of this stuff here in between the mean and the z of 0.98. So in between the mean and 0.98 is another 33.65%. So if you add these together, you get 83.65. Subtract that from 100, you're going to get 16.35%. So that's an alternative but mathematically equivalent way of answering this question. Now let's look at a very closely related question, which is what percent is below z equals 0.98. Again, I encourage you to draw the normal distribution as you work through any of these problems. And we want the percent below 0.98. So 0.98 is the z-score we're interested in, so that's going to be here. And the percent below will include that and all of this. Okay, well, one way to solve this would be to add everything below 0 to everything that's relevant above 0. So this whole half is 50% because it's a symmetrical distribution. So we don't even need the z-table for that. And now to get this, we need the z-table. So our z-score is 0.98, and we want between the mean and the z-score, percent between the mean and the z-score. So this here is 33.65%. And the question's asking what's total below, so we have to add these together. 50 plus 33.65 is going to give us 83.65%. So there's 83.65% of this distribution is below a z-score of 0.98. And of course, you could have also solved it by figuring out what percent is above and subtracting that from 100, and it would give you the exact same answer. All right, so now we're going to try another kind of problem. Here we're going to look at what z-score has 16.60% above it. All right, so last time we were given the z-score, had to figure out the percent. Now we're given the percent, we have to figure out the z-score. So again, I strongly encourage you to draw your normal distribution and identify the part you need to calculate. And we're looking for what? Z-score has 16.60% above it. So we want a score with 16% above it. So it's going to be something like this, but we don't actually know what the z-score is. But it's going to be above, but we want 16.6% to be above it. So the easiest way to do this kind of problem, since we're looking for above or more extreme in the tail than that z-score, is to use this column here, percent in the tail. And then what we can do is we can look through here until we find the percent that's closest to it. So this percent in the tail, the percent beyond, isn't big enough. This one's not big enough. This one's not big enough. Here we go. So a z-score of 0.98 has 16.60% above it. So that answers the question. So a z-score of 0.98 has 16.60% above it. Okay, so now we're going to do a very similar problem to this one, but slightly modified. So here we want to figure out what z-score has 16.60% below it. So it's very similar. Before we looked at what z-score had that percent above it, now we're looking for below it. So as always, start off drawing our normal distribution. And now we want our 16.60% to be below the z-score. So it's going to be below. So it's going to be, the percent's going to be over here someplace. Right? And so it's going to be 16.60%. And what we're trying to figure out is the z-score for that cutoff. So again, this problem is set up such that the easiest way to solve it is to look for the percent in the tail beyond the z-score, which is this column here, right? And so we want it to be 16.60, right? We already found that last time. So a z-score of 0.97 has that percent beyond it. But now we're over here in the negative values. So that means that we're going to need a negative z-score. So the z-score here is negative 0.97. So a z-score of negative 0.97 has 16.60% beyond it. So that's how you would answer that question. Okay, so now we're going to look at an even more complicated kind of a problem that you can solve with this table. And so this is what percent is between negative 0.97 and z equals 0.99. So we will draw our normal distribution. You've probably noticed these do not need to be exact. And so we're looking for between. Between z equals negative 0.97 and positive 0.99. So we want all of that area. So we're going to have to figure them out separately and then add them together. So let's just start with the part below the mean. So 0.97. It's negative, so that's fine because we're interested in this half over here. And the percent between the mean and that z-score, that is 33.40%. And over here, negative 0.97. 0.99. Okay, and then part over here, 0.99 between the mean and the z-score, that is 33.89%. The question's asking us all of that total, so we have to add these together. 33.40 plus 33.899276. So 67.29% of this whole distribution is between a z-score of negative 0.97 and a z-score of 0.995. Okay, now we're going to do a related problem. Here we want to look at, instead of what's between, what's outside. So what percentage of scores are outside of z equals negative 0.97 and z equals 0.99. So I'll draw the normal distribution. And figure out what we want here. So 0.97, negative 0.97. So right around here. So it's outside of it. So we want all of that. And then z equals 0.99 is over here. So we want to add up all of that. Okay, so we need to figure out this half and that half separately. And then add them together to be able to answer this question. So let's start off with this left side here. So we need 0.97. And here we're interested in the area that is in the tail beyond the z-score, percent in the tail beyond the z-score. So this is 16.60%. And over here we have 0.99, and we're again interested in the percent that's in the tail beyond that z-score. So that is going to be 16.11%. We need to figure out the sum of those two, so we'll add them together. 16.60, 16.11, 17, 32. So the answer is that 32.71% of the area of the overall curve is outside of z equals negative 0.97 and z equals 0.99. Okay, so for the last example problem, we're going to start with a raw score and have to turn that into a percentile. So there'll be a few steps involved for this kind of a problem. So here we want what is the percentile for a woman who is 61.53 inches tall. Okay, so this is in the unit of inches, and this is in z-score units, units of standard deviation. So we can't use this table yet. First, we need to change this number, transform this number into a z-score. So we know the population mean for women's height, 65 inches. The population standard deviation for women's height, we got 5 inches. And then we can use the z-score formula, populations, to change this raw score into a z-score. So her height goes there. Subtract the mean of 65 divided by 3.5. Down here, 61.53. I did the math earlier, and what I got was z-score equal to negative 0.99. So now we need to figure out what percentage of scores is below this z-score. So we'll draw our distribution. 0, 1, 2, 3, negative 1, negative 2, negative 3, and we're interested in negative 0.99, and it's a percentile, so all the scores that are below. So now what we can do is we can go to the z table, and we can look at 0.99, which is conveniently in the excerpt that we have here. And what we need is the percent of the distribution that is in the tail beyond our z-score. That's right here. So 16.11% is that area. So the percentile, that is the percentile in this case, so it's nice that we've already solved the problem. So the percentile for a woman who is 61.53 inches tall, that percentile is 16.11%. Or to translate that into regular language, about 16% of women would be shorter than a woman who's 61.53 inches tall.